Okay, today you're talking about geometric sequences. The way your teacher explains a geometric sequence is that the terms in the sequence are terms from exponential functions because you're multiplying by the same number each time. When you have 2 to the x, it's 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. You're multiplying by 2 each time. An extra factor. Well, that's what happens here. With arithmetic, it's more linear. Well, with geometric, you're multiplying. You don't have a common difference like you did with arithmetic. You have a common ratio, which they typically call r, and r is not equal to 1. Because if your ratio is 1, then you're just multiplying by 1 and the numbers never change. A common ratio of 1 is the same as having a common difference of 0 in an arithmetic. The number stays the same all the way through. Now, if you want to find the common ratio, you take 2 consecutive terms. It doesn't matter if it's the first 2, the middle 2, it doesn't matter. Take 2 of them and put the latter over the former. That means if you take the first 2, you put the second one over the first one. If you take the second and the third, you put the third one over the second one. It's always the one that follows over the one before it. And then you simplify this fraction, this ratio. So here's a couple of examples. It says find the common ratio r of each geometric sequence. So this is problem 2 on your assignment here, where you're taking any 2 numbers. I just take the first 2. The ratio would be the second one over the first one. It'd be 6 over 3, which is 2. There's your common ratio. That's pretty easy. You say, well, what if I took these 2? 12 over 6, that's 2. Take these 2, 24 over 12, that's 2. Okay? Down here, they're asking you to do the same thing. Now notice, here the numbers are getting bigger. Your ratio is bigger than 1, so the numbers are increasing. But here your numbers are getting smaller. So your ratio here is, it's still positive, but it's between 0 and 1. They're getting smaller, they're decreasing, like growth and decay here. So in this case, I take any 2. I'll just take the first 2 again, although if you took the last 2, the numbers are smaller. And you put the second one over the first one. As it turns out, 68 goes into that one, 68 goes into that twice. So your common ratio is a half. So just take any 2 consecutive. It's the second one over the first one. If you take these 2, the third one over the second, and so on. Now, he throws in some problems that ask for you to determine if the sequence that's given is arithmetic, geometric, or neither. That's supposed to be an or neither. I didn't get a very good word or in there. If it's arithmetic, you're to find the common difference, d, and if it's geometric, you're to find the common ratio, r. So this should have a comma here, and this should be or. There we go. So I look at the first one. Now to do this, I'm going to use the idea of finding a common difference or finding a common ratio. So I'll start out with arithmetic, and I'll take these first two terms, and 3 minus 1 is 2. Take the next 2, 7 minus 3 is 4. Stop. They don't have a common difference. First couple already have numbers that are different here. So let me see if it's got a common ratio. Take the first 2, that would be 3 over 1. Take the next 2, that would be 7 over 3. Stop. Those are not the same numbers either. So it's not arithmetic, it's not geometric, so this one's a neither. I look at this guy down here. Let's try arithmetic first. So I take the difference, second minus first, negative 1 minus 3 is negative 4. Take these 2, negative 5 minus a negative 1 is negative 4. It's looking good. Take the last 2 here, negative 9 minus a negative 5 is negative 4. I get the same difference each time. So this is arithmetic. And my common difference is negative 4. They ask for both things here, so make sure you list both things. Now, I didn't do an example that's geometric because most of these problems are geometric, so you're going to get plenty of chance to see those. But if this hadn't been arithmetic, then I would have looked at the ratios to see if the ratios were the same, to see if I had a common ratio. Now it says to write a rule or formula to find the nth term of each geometric sequence described. So as soon as I know it's geometric sequence, this guy right here, which I need to memorize, is how I find the nth term. To find the nth term, you need the first term and you need the ratio. So that's exactly what they give me. Oh no, they didn't give me the first term. They gave me the third term. Ooh, this is going to be interesting. So a sub n is equal to a sub 1, excuse me, r to the n minus 1. Well, I don't know what n is, but, or take that back, I will know what n is. N is 3 here. So I'm going to use this as a sub n is 3. So a sub n, a sub 3, which would be a sub 1, r, which is 6, to the 3 minus 1 power, put the 3 in here for the n, has got to equal 72. Oh, see, I get an equation out of this. So this is a sub 1, 6 to the second power. So I get 36 a sub 1 equals 72. Divide by 36. I get a sub 1 is equal to 2. Alright, back we go. We're going to go to here because they want the rule or the formula. That's this guy. I'm going to put it out here. So a sub n is equal to a sub 1, which we now know is 2. R, which we know is 6, to the n minus 1 power, because they want the general rule there for the nth term. So I had to get a little snazzy here and make the substitution to find out what a sub 1 was, and then I could plug in and write out my rule. Here I've got a little bit more of the same, except they didn't give me r, but they did give me 2 of these. So again, go back to this guy right here, and we'll start with a sub 3. So n is 3, and I'm going to get a sub 3, which is going to be a sub 1, my r, which I do not know, but to the 3 minus 1 power. And this is equal to 10. That's my a sub 3, right? It's 10. So I have this. I have a sub 1 r squared is equal to 10. Well, I still have 2 unknowns. Better get something out of here. So now I'll do the whole thing over again, but this time I'll start out with a sub 6. That's a sub 1, which again we don't know. R, which we don't know. And in this case my n is 6, so this would be 6 minus 1. Or this would be, and which is negative 270. Kind of going into this spot here a little bit. So that tells me that this is a sub 6. That tells me this is equal to negative 270, or a sub 1 r to the 5th power is equal to negative 270. Okay, well what I'm going to do here is I'm going to solve. I have 2 equations with 2 variables, the same 2 variables, r and a sub 1. So I'm going to solve for one of these, and I'm going to use substitution and solve this system of equations. So what I'll do here is I will solve for a sub 1 by dividing this first equation by r squared, and I get a sub 1 is equal to 10 over r squared. And now I'm going to plug that into this equation right there, right in for a sub 1. All of this goes right in here. So I get 10 over r squared times r to the 5th power is equal to negative 270. Well, this better give me r. Now I have an r to the 2nd power in the denominator. I have an r to the 5th power. These cancel. 2 of these cancel with 2 of these. That leaves 3 factors of r. So I have 10 r to the 3rd is equal to negative 270. Divide by 10. I have r to the 3rd is equal to negative 27. Well, take the cube root of both sides. What number times itself again is negative 27. It's negative 3. And if r is negative 3, I can plug negative 3 right back into here and find a sub 1. A sub 1 is equal to 10 over negative 3 squared, which is 10 over 9, positive 9. So there's my a sub 1, there's my r. I can write, I'm going to put it way over here, guys, way over here, and I'm going to write this as a sub n is equal to, I need a sub 1, that's 10/9. I need my ratio, it's negative 3, and it's always to the n minus 1 power. And that's as far as this one goes. There's my rule. That one had a little bite to it. That was not a simple problem. You had to solve a system of equations. All right, I have a couple more examples over here. This first one's got 2 different parts to it. In the first part it says, in part A, find the sum of the first n terms of the series. Okay, I forgot to write down how many terms there were. This is problem number 19. So for part A, I have n equals 18. And for part B, I have S sub n is equal to 3,829. I hope I have my calculator close by. It's a pretty good sized number. All right, so for the first part, you're to find the sum of the first n terms of the series. Oh, I'm going to need the formula for finding the sum of the series. Now remember, a series, it just means you're adding up the terms of a sequence. So like here's a sequence right here. 1, 3, 7, 13, and so on. Here's the corresponding series, 1 plus 3 plus 7 plus 13 plus and so on. So the series is when you add the terms. The sequence is when you list the terms. Now, I don't have the formula written down, and I think I remember it. The formula for adding up the terms, I'm going to have to erase a little bit of this. I'm going to get rid of this spot right here so that I have room to write it out. Okay? So, to find the sum for a geometric series, okay, S sub n is equal to, let's see if I can remember this. This is n times the quantity 1 minus r, no, not n. A sub 1 times the quantity 1 minus r to the n all over 1 minus r. I believe that's it. It's probably written down on your first page of your worksheet. Let's see. Nope. But he did write it in his notes. Now, I don't know if he gives you notes every single time like this, but if he does, you should try to print these notes out and use them. It's always nice to have extra examples. Anyway, you can see it right there. At least I think I can see it right there. There you go. All right, so that's the one we're going to do. Now, he wrote his a sub 1 out in front. It doesn't matter. If that makes it easier for you, then that's fine. So there's my a sub 1. I need to know what r is. My r is going to be the common ratio, so I'm going to take the 7 and the negative 21 and write the ratio. It's negative 3. So I need a sub 1 and I need r and I need n, and they give me that. Now notice, in the arithmetic, you needed the